Hello viewers, welcome. So in this tutorial I am going to make a custom model which will predict handwritten digit. So let's dive in, and I will be using TensorFlow obviously. So import TensorFlow STF. Now I'll be needing some I'll be need numpy. So import numpy as np, import matplotlib lib.pyplot as plot. Okay, now matplotlib.pyplot as no, there is an error. Okay, fine. Now I am going to make some hyperparameter. So parameters, learning rate. So learning rate equal to 0.001. Then I'll be making some training epoch. So the training epoch equal to 6. Then give out their base size, so that is 600. Okay, now import the datasets. So I'll be using MNIST dataset of handwritten digits. So for that reason, xtrain out there, y test, y train, then x test, y test out there, then write out there TensorFlow datasets mnist load data. Okay, now let me show you the shape of my data. So there are 60,000 data for training and test dot shape, and there are 10,000 data for test, and I want to see some of the data for I in range of 25. Now plot dot subplot, pass out there 5, 5, I plus 1, and give out there plot dot imshow, give out there x test out there, pass out there I. Okay, now plot dot show. Okay, let me wait. So these are the data, these are the handwritten digits. Now I want to classify these images, but I will be making a custom model instead of taking help of Keras here. And there is another thing, we usually use batch size. That is, if I use 60,000 data at a single time, then it will need a huge CPU, but I can divide this data into a small one. So for that reason, let's say I will take 600 data in each time for training, and for that reason I have given out there 600 as the base size. So the train data, the 60,000 data will be divided into 60, each time it will take 600 data when training. So for that reason I have to make the data iterable. Okay, so train dataset equal to, give out the bracket, now write out there train dataset dot. Okay, before doing so, okay, just continue. So write out the TensorFlow dot data dot dataset dot from tensor slices. Now I'll be passing here tf dot reshape x train. So I'll be making a huge function here, so just copy me here. So what I have done here, so you can see I've taken the x data, x train here, and x test, and y train here, y test, and take out there and call a function from tensor slices and make a batch of batch size and shuffle the data, and the shape of data was 28 by 28. Now I have made the flattened the data and made it into 784. Okay, so this is what I have done here. Okay, so I am doing another thing, just follow me here. So you can and now what I've done, that I have divided the test data, okay, and train data into, and that is I have normalized my data, and for the outputs I have made one hot encoding. Okay, so this is the lines which will perform this function. Now I am going to make the model. So let's go. For that reason, w equal to tf dot variable, and pass over there tf dot zeros. So just I am holding the positions, and here and for w I am using 10 neurons. So the shape of the input is 784 and number of neurons is 10. So the shape of w will be 784 by 10. Now I am making the bias. So tf dot variable, pass out there TensorFlow dot zeros, and I want to make 10 biases out there. Okay, so this is what the w and b for 10 neuron and single layer. Now I want to make the model. So model equal to lambda and x, such that I will be passing this one to softmax. Okay, before doing so, let's tf dot mathmal. So I will multiply the x with w, and then I'll sum it with, so tf dot sum or add with, I will sum it with b, the bias, and I'll pass the whole thing with tf dot nn dot softmax. Okay, so now I'll compute loss equal to lambda true value and the predicted value. Now I will be tf dot reduce mean and pass out there the tf dot reduce. What should I pass out there? Okay, reduce sum out there, tf dot reduce sum. Okay, reduce sum, and then I want to tf dot losses and binary cross entropy, and pass out there true value and pass out their predicted value. Okay, fine. So this is my loss function where it will calculate the loss for each prediction. Now I want to compute the accuracy. So just accuracy, just define another lambda function. So true and print and give out their TensorFlow dot reduce mean and tf dot I have to find okay I have to take the help of tf dot keras dot categorical accuracy and pass out their true value and the critical. Okay, so I'm done with my compute accuracy function. Okay, so now done. Now I have to define the optimizer. So optimizer equal to TensorFlow optimizers. So I am taking the help of Adam optimizer and give the learning rate over there. So which I have defined over there. Learning rate. This is the learning rate, which is a hyperparameter. So my model is done, compute loss function is done, compute accuracy is done, and optimizer is done. Now I have to train my model. For that reason, for epoch in a range of training epoch, so I have given training epochs equal to 6. So I will go through the whole training data for 6 times. Okay, and now I have to take the help of for I x y in enumerate, pass out there the train data set. Okay, now I have to take the help of TensorFlow gradient tab. So gradient tab as T as tab. Now I will be defining the prediction value. So prediction equal to model and pass out the x. Now loss equal to compute loss. So this is the loss, and I have to give out there the y value and the prediction value. Now so this is the word, and you can see I am passing each of the train data here for prediction, and I am passing this predicted value to the loss function to calculate the loss, and this is the true value and this is the predicted value. Now this function will calculate the total loss over there. Now I want to find the accuracy equal to compute accuracy and give out there the predicted the true value, so true y, and give out there predicted value. Now I want to find the grades. Now compute, so tab, so I want to differentiate this loss function with respect to w and b, so that I get the dw and db. So here tab dot gradients and pass out there loss and pass out there w and b. Now I will need this gradient value to optimizer dot apply gradient and zip out there the grades and the wb. Okay, fine. Now I want to see the result in each epoch. For that reason, loss percent 0.2 and egg percent 0.2f Okay, fine. So these are the two things I want to track. Now percent right out there, loss dot numpy, and I want to see accuracy dot numpy. Okay, done. So I'm done. Let's train the model. So there is an error. Let's check. Okay, I got the error, and here is the error, and matrix. I have to add matrix out there. Matrix categorical accuracy. Okay, that should be fine. Let me. Okay, so trap dot gradient, and in the percent to f. Okay, fine. And here is the, so you can see I'm getting losses, and the accuracy out there, it is increasing gradually, and to the last one I got an accuracy of 90%. So let me see the X test out there. So let me see X test, so the shape, and it is of 10,000 data out there, and each of them is 28 by 28. And if I see one of the image out there, okay, so the data is not normalized and the data is not flattened. So first of all, I'll be flattening my data. So tf dot reshape my X test data, give the shape out there -1, and give out there 28 into 28. Okay, now I want to test equal to X test. Let me, okay, X test, let's divide by 255.0. okay, I'll get an error. Let me see. So it is a tensor, and okay, I have to take the help of tf dot divide and pass out there X test over there, and pass out there 255.0. So okay, there is an error. Okay, before doing this, I want to tf dot cast, pass out the X test. Now tf dot float 32. That should work now. Okay, I got X test now. Let me see one of the data of X test, and you can see it is converted to, it is normalized now. Now I want to feed this data to have a prediction. So prediction equal to, I have to pass this to my model, so model, and give the test data out there, so X test, and now I got the prediction, and it is a tensor. Okay, and I want to see the result through graphing. For that reason, did I import numpy? Okay, I import numpy. Now plot dot figure, give out their fixed size, eight by 8. Now for I in range of 25 plot dot subplot, give out there 5 comma 5 I plus 1. Now plot dot imshow, so x test dot 0 dot numpy. Okay, so yeah, so let me see the images first. Fixed size is not defined. Okay, I got another error out there. Okay, so I fixed the error here. Now I have to reshape my image. So for showing the image and for prediction, I have flattened my data. Now I have to reform the image into 28 by 28 to show. So for that reason, I use numpy.reshape and pass the x test, and that is the 0th element. So just pass the ith element and dot numpy. So I bring the numpy value from the tensor and give the size of reshape equal to 28 by 28. Okay, so now I want to plot dot x level, give out there with the name. So I want to numpy dot argmax, and from prediction dot 0 dot I dot numpy. I want to find the argmax from here, and this is what I want to, okay, this is all I want to print, since the 0 and the index are same, the class name and the index are same. Okay, so plot dot xstreak, sticks out there, keep out the blank. So let me see the result here. Oh, xsticks, why I'm getting error? So I fixed out the error, and this is what I was writing TIC-TS. So I should change this one to ticks. Now let's see the result, and you can see this is 7 out there, and here is the prediction of 7, 2 out there, 2, 1, 1, 0, 0, 4, 4. So the main purpose of this tutorial is to have a better intuition how the layers, the different layers which we take help of keras, we get better intuition. So this is all for this tutorial. In the next tutorial I will be showing you multi-layered perception. So this is all for this tutorial, and thanks for watching.